feeling when you leave a doctor's office and you're actually more confused than when you went in? They're using all these complicated words, pathology, etiology. It's like they're speaking a totally different language. Well, today, we're going to be your translator. We're going to dive right into the fundamental language doctors use so we can really understand what it means when we talk about disease.
We throw this word around constantly, right? But what does it actually truly mean from a medical standpoint? It sounds like a simple question, but trust me, getting this one definition right is the absolute key to unlocking everything else we're going to talk about. It is the bedrock of modern medicine.
Okay, so the most important place to start is with the field itself, pathology. Just think of it as the science of what goes wrong in the body. It's not just about, slapping a name on an illness. It's all about understanding the before and after picture on a biological level. All those little changes that take a healthy body and turn it into a sick one. And here it is, the star of our show, the actual definition of a disease. At its core, it's any kind of departure from the normal way your body's supposed to be built or how it's supposed to work. But here's the really critical part. That departure isn't just random. It shows up as a very specific, recognizable pattern of signs and symptoms that a doctor can identify. Now, as you can imagine, pathology is a massive field. So to make any sense of it, it's basically split into two major branches. Understanding this split is kind of like having a map. It shows you both the major highways that are common to all diseases and the specific local roads that lead to problems in one particular part of the body. So here are the two sides of that coin. On one hand, you have general pathology. This is the big picture stuff. It looks at the basic reactions, like inflammation, that can pretty much happen anywhere in your body. But then you've got special pathology, and this is where we zoom in. It asks, okay, but what does inflammation look like specifically in the lungs? It's the difference between knowing the general rules of a game versus knowing exactly how to play on one specific field. So how do pathologists figure all this stuff out? Well, they don't just take a wild guess. They have a really systematic 4-part framework. Think of it as their roadmap for understanding any disease, from where it started to what it does to you. And here is that roadmap. It's so cool. First up is etiology. Why did this happen? Was it a virus? A bad gene? Next, pathogenesis. How did it unfold? What's the step-by-step story inside the body? Then, morphologic changes. What does the damage actually look like under a microscope? Are the cells different? And finally, clinical significance. So what? What does this all mean for the person? What are the symptoms they're actually feeling? Let's just double-click on pathogenesis for a second because it is so important. This isn't just the cause. It's the entire story. It's a whole chain reaction, that domino effect that starts with the initial trigger and goes all the way to the final cough or fever. You could honestly call it the biography of the disease.
All right, so if pathogenesis is the story, then etiology is chapter 1. This is always a starting point for any investigation. Where did this thing come from? And almost always, the cause is going to fall into one of two major buckets. And it's a pretty simple but incredibly powerful distinction. Is the cause genetic? Meaning, is it baked into your DNA, something you were born with? Or is it acquired, something that happened to you, something you picked up from the world? Answering that first question can completely change the game in terms of how you treat or even prevent a disease.
And when you look at the list of acquired causes, man, it is huge. Just think about all the things from the outside world that can make us sick. We're talking about physical things like an injury or radiation, chemical poisons, not getting the right food, and of course, the big one, infections. But it also includes your own immune system going haywire, or even psychological factors like stress. It's a lot. Okay, but to really understand how any of these things, whether it's a virus or a physical injury, actually causes damage, we have to go smaller. I mean, way smaller. We've got to zoom right past the organs, past the tissues, all the way down to the fundamental building block of life, the place where health and disease really begins, the cell. I want you to picture a single cell as this tiny, bustling city, and every part inside it, every organelle, has a super specialized job. The nucleus, that's City Hall, where all the DNA blueprints are kept. The mitochondria, those are the power plants generating all the energy. Ribosomes are the factories churning out essential proteins. Lysosomes are the sanitation crew, the digestive system. And the endoplasmic reticulum, that's like the city's detox center. A disease usually kicks off when one of these little specialists just can't do its job anymore. So why do we care about all these definitions? Because this framework, this language, it's literally the foundation of all medicine. Think about it. When a doctor says you have the flu, they are using these exact concepts. They know the etiology. It's a virus. They know the pathogenesis, how that virus gets into your cells and starts multiplying. They can see the morphologic changes, inflammation in your airways. And all of that adds up to the clinical significance, the fever, the cough, the aches you feel. So now, the next time you hear about some new disease on the news or a medical breakthrough, you'll have the tools to get what's really going on. You'll know the questions you should be asking. What's the cause? What's the process? What's the damage? And what does it feel like? Because when you understand how things break, well, that's the very first step to figuring out how to fix them. And that's a pretty powerful perspective to have, don't you think?